This is an open access article distributed under the terms of the Creative Commons Attribution License, which permits unrestricted use, distribution, and reproduction in any medium, provided the original authors and source are cited. 10 simple rules for reading a scientific paper. This paper is published in PLOS Computational Biology. It's by the authors Maureen Carey, Kevin Steiner, and William Petrie. All of them are at the University of Virginia. And this is an open access paper. Introduction. There is no problem that a library card can't solve, according to author Eleanor Brown. This advice is sound, probably for both life and science. But even the best tool, like the library, is most effective when accompanied by instructions and a basic understanding of how and when to use it. For many budding scientists, the first day in a new lab setting often involves a stack of papers, an email full of links to pertinent articles, or some promise of a richer understanding, so long as one reads enough of the scientific literature. However, the purpose and approach to reading a scientific article is unlike that of reading a news story, novel, or even a textbook, and can initially seem unapproachable. Having good habits for reading scientific literature is key to setting oneself up for success, identifying new research questions, and filling gaps in one's current understanding. Developing these good habits is the crucial first step. Advice typically centers around two main tips: read actively and read often. However, active reading, or reading with an intent to understand, is both a learned skill and a level of effort. Although there is no one best way to do this, the authors here present 10 simple rules relevant to novices and seasoned scientists alike to teach their strategy for active reading based on experience as readers and as mentors of undergraduate and graduate researchers, medical students, fellows, and even early career faculty. Rules 1 to 5 are big picture recommendations. Rules 6 to 8 relate to philosophy of reading. Rules 9 to 10 guide the now what questions one should ask after reading and how to integrate what was learned into one's own science. Rule 1. Pick your reading goal. What you want to get out of an article should influence your approach to reading it. Table 1, which we will review in a moment, includes a handful of example intentions and how you might prioritize different parts of the same article differently depending on your goals as a reader. Rule 2. Understand the author's goal. In written communication, the reader and the writer are equally important. Both influence the final outcome. In this case, your scientific understanding. After identifying your goal, think about the author's goal for sharing this project. This will help you interpret the data and understand the author's interpretation of the data. However, this requires some understanding of who the authors are. For example, what are their scientific interests? The scientific field in which they work. For example, what techniques are available in the field, and how this paper fits into the author's research. For example, is this work building on the author's long-standing project or a controversial idea? This information may be hard to glean without experience and a history of reading. But don't let this be a discouragement to starting the process. It is by the act of reading that this experience is gained. A good step toward understanding the goal of the authors is to ask yourself, what kind of article is this? Journals publish different types of articles, including methods, review, and commentary, resources, and research articles, as well as other types that are specific to particular journal or groups of journals. These articles typically have different formatting requirements and expectations for content. Knowing the article type will help guide your evaluation of the information presented. Is the article a methods paper, presenting a new technique? Is the article a review article, intended to summarize a field or problem? Is it a commentary, intended to take a stand on a controversy or give a big picture perspective on a problem? Is it a resource article, presenting a new tool or data set for others to use? Is it a research article, written to present new data and the author's interpretation of those data? The type of paper and its intended purpose will get you on your way to understanding the author's goal. Rule 3. Ask 6 questions. When reading, ask yourself, 1. What do the authors want to know? In other words, what is their motivation? 2. What did they do? What was their approach or method? 3. Why was it done that way? 4. What do the results show? Here you would look at figures and tables. 5. How did the authors interpret the results? 6. What should be done next? Regarding this last question, the authors may provide some suggestions in the discussion, but the key is also to ask yourself what you think should come next. Each of these questions can and should be asked about the complete work, as well as each table or figure or experiment within the paper. Early on, it can take a long time to read one article from front to back, and this can be intimidating. Break down your understanding of each section of the work with these questions to make the effort more manageable. Again, this is Ask 6 Questions, Rule 3. Now let's look together at Table 1. The table is titled Reading Intentions and How It Might Influence Your Approach. And in this table, you will see that there are 5 examples. We're going to look at those now. So we have the examples, the intention, and priorities. So example 1, intention. You are new to reading scientific papers. So what would be your priority? For each panel of each figure, focus on the questions outlined in Rule 3. Example 2. You are entering a new field and want to learn what is important in that field. So the priority would be, or might be, focus on the beginning and the end. Motivation presented in the introduction and the end. The next step presented in the conclusion. The third example, you receive automated alerts to notify you of the latest publication from a particular author whose work inspires you. You are hoping to work with them for the next phase of your research career and want to know what they are involved in. So what might your priority be? Skim the entire work, thinking about how it fits into the author's broader publication history. And let me note here, this is a really great idea. Item 3, if you are interested in working with somebody, being alerted about their publications is a great idea. Example 4, you received automated alerts to notify you of the latest publication containing a set of keywords because you want to be aware of new ways a technique is being applied or new developments in a particular topic or research area. So what might your priority be? Focus on what was done in the methods and the motivation for the approach taken. This is often presented in the introduction. Example 5, the intention. You were asked to review an article prior to publication to evaluate the quality of work or maybe to present it to a journal club. For priorities, same as the example in number 1. Also, you might ask, do the data support the interpretations? What alternative explanations exist? Are the data presented in a logical way? If the research is about a controversial topic, do the authors appropriately present the conflict and avoid letting their own biases influence the interpretation? Rule 4, unpack each figure and table. Scientists write original research papers primarily to present new data that may change or reinforce the collective knowledge of a field. Therefore, the most important parts of this type of scientific paper are the data. Some people like to scrutinize the figures and tables, including legends, before reading any of the main text, because all of the information should be obtained through the data. Others prefer to read through the results section while sequentially examining the figures and tables as they are addressed in the text. There is no correct or incorrect approach. Try both and see what works best for you. The key is making sure that one understands the presented data and how it was obtained. For each figure, work to understand each X and Y axes, color scheme, statistical approach, if one was used, and why the particular plotting approach was used. For each table, identify what experimental groups and variables are presented. Identify what is shown and how the data were collected. This is typically summarized in the legend or caption, but often requires digging deeper into the methods. Do not be afraid to refer back to the methods section frequently to ensure a full understanding of how the presented data were obtained. Again, Ask the questions in Rule 3 for each figure or panel and conclude with articulating the take-home message. Rule 5, understanding the formatting intentions. Just like the overall intent of the article that was discussed in Rule 2, the intent of each section within a research article can guide your interpretation. Some sections are intended to be written as objective descriptions of the data, for example, the results section, whereas other sections are intended to present the author's interpretation of the data. Remember, though, that even objective sections are written by and therefore influenced by the author's interpretations. Check out Table 2, which we will consider in a moment, to understand the intent of each section of a research article. When reading a specific paper, you can also refer to the journal's website to understand the formatting intentions. The For Authors section of a website will have some nitty-gritty information that is less relevant for the reader, like word count, but will also summarize what journal editors expect in each section. This will help to familiarize you with the goal of each article section. All right, now let's look at Table 2, the structure of a primary research article. And this table has several, is broken up into section and content. And let's just now review that together. So we begin with the title. And the title is the take-home message of the entire project according to the authors. Then you'll see the author list. These are the people who made significant contribution to the project. And different fields differs the standard practice for ordering the authors. For example, as a general rule, in biomedical sciences, the first author led the project's implementation, and the last author was the primary supervisor of the project. Then you'll see the abstract, which is a brief overview of the research question, approach, results, and interpretation. It's the roadmap or the elevator pitch for the article. Next, we will see the introduction, several paragraphs to present the research question and why it is important. A newcomer to the field should get a crash course on the field from this section. Then we see the methods, what was done, how was it done. Ideally, one should be able to recreate a project by reading the methods. In reality, the methods are often overly condensed. Results is the next section, what was found. The paragraph often begins with a statement like, to do X, we use approach Y to measure Z. Then we see figures, tables, and legends. The data are presented in these figures and tables. Then we jump to the discussion. What do the results mean? And how do they relate to previous findings in the literature? Then the conclusion, which is a brief summary of the implications of the results. And references, which is a list of previously published papers, datasets, or databases that were essential for the implementation of the project or interpretation of the data. This section may be a valuable resource listing important papers within the field that are worth reading as well. Then we see the supplemental materials. That's any additional methods, results, or information to support the results or the interpretations. And sometimes next we see after that supplemental data, essential data sets that are too large or cumbersome to include in the paper. Rule 6, be critical. Published papers are not truths etched in stone. Published papers in high-impact journals are not truths etched in stone. Published papers by bigwigs in the field are not truths etched in stone. Published papers that seem to agree with your own hypotheses or data are not etched in stone. Published papers that seem to refute your hypotheses or data are not etched in stone. Science is a never-ending work in progress. And it is essential that the reader pushes back against the author's interpretation to test the strengths of their conclusions. Everyone has their own perspective and may interpret the data in different ways. Mistakes are sometimes published, but more often these apparent errors are due to other factors, such as limitations of a methodology and other limits to generalizability. This could be selection bias, unaddressed or unappreciated confounds. When reading a paper, it is important to consider if these factors are pertinent. Critical thinking is a tough skill to learn, but ultimately boils down to evaluating data while minimizing biases. Ask yourself, are there other equally likely explanations for what is observed? In addition to paying close attention to potential biases of the study or authors, a reader should also be alert to one's own perspective and biases. Take time to ask oneself, do I find this paper compelling because it affirms something I already think or wish is true? Or am I discounting their findings because it differs from what I expect or from my own work? The phenomenon of a self-fulfilling prophecy or expectation is well studied in the psychology literature, and why many studies are conducted in a blinded manner. It refers to the idea that a person may assume something to be true, and their resultant behavior aligns to make it true. In other words, as humans and scientists, we often find exactly what we are looking for. A scientist may only test their hypotheses and fail to evaluate alternative hypotheses. Perhaps a scientist may not be aware of alternative, less biased ways to test his or her hypothesis that are typically used in different fields. Individuals with different life, academic, and work experience may think of several alternative hypotheses, all equally supported by the data. Rule 7. Be kind. The authors are human too, so whenever possible, give them the benefit of the doubt. An author may write a phrase differently than you would, forcing you to reread the sentence to understand it. Someone in your field may neglect to cite your paper because of a reference count limit. A figure panel may be misreferenced as supplemental figure 3E when it's obviously supplemental figure 4E. While these things may be frustrating, none are an indication that the quality of the work is poor. So try to avoid letting these minor things influence your evaluation and interpretation of the work. Similarly, if you intend to share your critique with others, be extra kind. An author, especially the lead author, may invest years of their time into a single paper. Hearing a kindly phrased critique can be difficult but constructive. Hearing a rude or mean-spirited critique can be heartbreaking, especially for young scientists or those seeking to establish their place within a field and who may worry that they do not belong. Rule 8. Be ready to go the extra mile. To truly understand a scientific work, you will need to look up a term, dig into the supplemental materials, or read one or more of the cited references. This process takes time. Some advisors recommend reading an article 3 times. The first time, simply read without the pressure of understanding or critiquing the work. For the second time, aim to understand the paper. For the third read through, take notes. Some people engage with the paper by printing it out and writing all over it. The reader might write question marks in the margins to mark parts that he or she wants to return to, circle unfamiliar terms, and then actually look them up, highlight or underline important statements, and draw arrows linking figures and the corresponding interpretation in the discussion. Not everyone needs a paper copy to engage in the reading process, but whatever your version of printing it out is, do it. Rule 9. Talk about it. Talking about an article in a journal club or more informal environment forces active reading and participation in the material. Studies show that teaching is one of the best ways to learn, and that teachers learn the material even better as the teaching task becomes more complex. Such observations inspired the phrase, "To teach is to learn twice." Beyond formal settings such as journal clubs, lab meetings, and academic classes, discuss papers with your peers, mentors, and colleagues in person and electronically. Twitter and other social media platforms have become an excellent resource for discussing papers with other scientists, the public, or your non-scientific friends, or even the paper's authors. Describing a paper can be done at multiple levels, and your description can contain all of the scientific details, only the big picture summary, or perhaps the implications for the average person in your community. All of these descriptions will solidify your understanding while highlighting gaps in your knowledge and informing those around you. Rule 10. Build on it. One approach we like to use for communicating how we build on the scientific literature is by starting research presentations with an image depicting a wall of Lego bricks. Each brick is labeled with the reference for a paper, and the wall highlights the body of literature on which the work is built. We describe the work and conclusions of each paper represented by a labeled brick, and discuss each brick and the wall as a whole. The top brick of the wall is left blank. We aspire to build on this work and label the brick with our own work. We then delve into our own research, discoveries, and the conclusions it inspires. We finish our presentations with the images of the Legos and summarize our presentation on that empty brick. Whether you are reading an article to understand a new topic area or to move a research project forward, effective learning requires that you integrate knowledge from multiple sources and build upwards. Leveraging published work will enable you to build a stronger and taller structure. The first row of bricks is more stable once a second row is assembled on top of it, and so on and so forth. Moreover, the Lego construction will become taller and larger if you build upon the work of others, rather than using just your own bricks. Build on the article you read by thinking about how it connects to ideas described in other papers and within own work, implementing a technique in your own research, or attempting to challenge or support the hypotheses of the authors with a more extensive literature review. Integrate the techniques and scientific conclusions learned from an article into your own research or perspective in the classroom or research lab. You may find that this process strengthens your understanding, leads you toward new and unexpected interests or research questions, or returns you back to the original article with new questions and critiques of the work. All of these experiences are part of the active reading process and are signs of a successful reading experience. In summary, practice these rules to learn how to read a scientific article, keeping in mind that this process will get easier and faster with experience. We are firm believers that an hour in the library will save a week at the bench. This diligent practice will ultimately make you both more knowledgeable and a productive scientist. As you develop the skills to read an article, try also to foster good reading and learning habits for yourself. Good luck and happy reading.